New Zealand-grown hops make up less than 1% of the world's crop. The industry has set a target to double that over the next 15 years. In February this year, we visited hop breeder Dr. Ron Beatson from Plant and Food Research, who's working on speeding up selection of new hop cultivars.
The focus of our program is heavily around improving the genetics of hops for commercial production here in New Zealand. Hops are quite latitude sensitive, so most countries that grow hops have their own plant breeding programs, and likewise here in New Zealand we've done the same thing. It's been going since the Second World War. Initially the program was set up to obtain resistance to a root rot disease that was in the hops, and a lot of the material came originally from North America and also from Europe. All the hops that are grown in the world are now pretty much seedless, and most countries have taken the easy route to produce seedlessness, and that's having normal chromosome numbered plants, but they just remove male plants from their commercial growing. It's a wind pollinated plant, so if you remove the males, the females don't produce seeds, but they'll still form the cones, which is the female inflorescence, which is used for the commercial production of beer. In New Zealand we've taken a different path. We've decided to go with altering the chromosome numbers of one of the parents and then crossing it back to a normal chromosome number individual, and the progeny from that cross has got 3 sets of chromosomes. It's not genetically modified at all, it's a natural process, but it's just that they haven't got seeds. The main reason for seedlessness is in hop production is the fact that they impart impurities in the brewing process. They've got a lot of fatty acids in their seeds, and they give off flavours, to give the cheesy flavours to beers. The stars align for hops here in the Nelson area. It's got good soils, we've got high sunshine hours, 2,500 hours of sunshine. We don't have any problem with wind, which is a no-no for hop production. They're the 3 main ingredients: reasonably steady rainfall throughout the year, and there's enough cold in the winter time to give it some winter chill, which hops like. So there's a lot of reasons why Nelson is the place to grow it. New Zealand's pretty much a niche export market. In the late 70s, early 80s, it was producing very little in the way of export product. It was mainly a sort of a cottage industry which was supplying domestic brewers. But since that time, the area has rapidly increased. It's now double that production, and they're looking at the premium end of the market space in the craft brewing area in particular, mainly into the Pacific Rim countries, but also into Europe a little bit, UK. We've got markets in Asia, Japan in particular, and also into Australia, North America. We produce less than 1% of the world's crop, and the aim of the industry is to double that in the next 15 years to 2%. I think the future really lies in our hands in Plant and Food Research's genetics program. Developing new cultivars for the industry is going to keep them at the forefront of the craft brewing boom in particular. The cultivars that we've produced have been highly sought after, and our whole aim is really to focus on hops with a difference, which is our international difference, if you like. They're not only in the genetics, but in the fact that they're seedless triploids, but they're also got different flavours. All round, we're producing hops that have got interesting characters which the brewers are clamouring to get hold of. The hop plant botanically is very closely related to cannabis. They both grow wild in Central Asia, and their structure of the plant itself is quite similar. If you look at it closely, they've both got quite serrated leaves, and quite similar in terms of their appearance as a plant. They both sort of got male and female sexes separated on different plants, so there's a lot of similarities. It's a perennial plant. The below ground part is the perennial part of the plant. It's called a rhizome. Each spring the rhizome sends out new shoots which are responding to more heat. They grow up pretty quickly and form these long shoots which the growers then train up special strings like we've got here. So this plant back in September was just at ground level, so there's a fairly rapid growth of the plant, and by usually between October and November the plants are trained, and then by Christmas time the plants are over the top of the wire at 5 metres, and it's starting to send out side shoots, and it's from those side shoots that we form the flowers. So it's the female plant that's the plant of commerce. The cultivar I'm standing next to here is one called Motueka. So this is the female inflorescence, or the cone, and it's about 1 week away from harvest now. and the cone itself is made up of various anatomical features, but what the important thing in terms of the hop production is concerned is the yellow colour that you can see here. It contains all the good ingredients that are used in the brewing process, the business end of the hop production. These little yellow glands are called lupulin glands, and they contain the bittering compounds and also the aromatic compounds that are used in the brewing process. This is our relatively new pilot brewing plant, which was commissioned in September 2014, and it's part of our science studies around improving our hop cultivars. Some people might wonder why we've got a brew kit here. It's the end product really of the hop cultivar development. So we're trying to get new cultivars developed for the industry by using this brew kit to prove whether these hops make good beer. So that's in a nutshell. We got funding 2 years ago from the Ministry of Business, Innovation and Employment, and we've used some of the science that we have to develop. We've used this brewing kit to help tell the story around our new hop cultivars. So it's really the end product of our hop program.
This program was made with funding from New Zealand On Air.